for your presentation. I will present my talk that is about the mnemonic factor and Pythagoras. Well, the aim of this talk is to try to convince you that there is a new tool for the interpretation of ancient facts, sites, and data in the field of the astronomy. In particular, there is the mnemonic factor that could help to discover information that was hidden in the past that can bring new light in the evolution of mathematical knowledge. In particular, to give some ideas about how people like Pythagoras arrived to complex thinking, as it was the theorem that has his name. If we talk about Pythagoras, we can say that it is not necessary. That it's not necessary the Pythagoras known all the knowledge about him is reliable.
Δεν δουλεύει αυτό, πάμε να φύγω. Με πετάς πάνω να κάνω τη δουλειά μου εκεί, γιατί δεν βλέπω να κάνω.
Please.
Σταύρο, ακούγεστε.
Okay.
Due to this status as a founder of a sect, a religious sect, the early appearances of many traditional around his person came about. It seems that he was the son of a merchant in Mensark, and that the first of his life was spent on the island of Samos, the place where we are now in this meeting. But he could abandon his birth site to go to several parts in the world, in the ancient world, including not only Greece, but also other places like Italy. We have the main Pythagorean contribution is the formulation of the theorem that relates the length of the hypotenuse to those of the small size of a rectangle triangle. The sources of diverse parts of the world affirm that the 3-4-5 triangle, this is the Pythagorean triangle, or the known as Egypt sacred triangle, was known before, well before the Pythagoras was present in the world. In Egypt, Mesopotamia, China, and India, like this picture we have here, that comes from a book that is the Show-Bison hymn that reports knowledge about 1,000 years before Christ. In this case, we see the Pythagorean solution of the Pythagorean triangle, the triangle of size 3-4-5. In fact, Pythagoras has traveled to those places and many other places about. Then we know that issue, but we don't know exactly, or we don't know what are the facts we can give to arrive to the comprehension that number is the essence of all things intelligent by the senses. This phrase was one of the main contributions to science, to all the evolution in mathematics, in other parts of the development of knowledge of the world. In this case, the solution of the rectangle triangle is very easy to visualize the solution in this way, where these are sides but how Pythagoras managed to generalize this point is one of the things I want to know. Well, let's talk about arcastronomy and cultural astronomy. And in these fields, there has been growing as a multidisciplinary specialties. There are gaining importance in the methodologies and resources allowed to identify information hidden in the past due to the lack of written vestiges. In particular, arcastronomy has several tools that can be used to help researchers. In this case, I used the concepts related to the triangle that is made by the gnomon in red and the shadow with the ray that comes from the sun in the winter solstice and the other in the summer solstice. And the relation of this is this right triangle is about which part I want to talk. Let me take a phrase that is important to this part of the mathematical evolution. An unnecessary restrictive view has been taken by confining our study of the history of mathematics to written evidence. Mathematics initially came from the need to count and record numbers, which may well have been done by comparing a collection of objects with some easily manageable sets of markers, whether these were pebbles, knots, or inscriptions, such as notches in the wood or a bone. This idea has that we need to go further from the written evidence and try to get, and I know that we can have this knowledge from the vision, no matter of which one of the two Greek, two different world visions we have. The Ptolemaic vision establishes also the solstices very clearly, and in the case of the Copernican vision, it is also very well known that the latitudes at the Cancer and the tropical Cancer and the tropical of Capricornus show that vision. Then, from this knowledge, we have to advance. What is exactly the mnemonic factor? That is the point I'm talking about. One is such the mnemonic factor was introduced almost 20 years ago for the study of a Stonehenge monument. Mainly, the talks of relations between the heights of the trilithons and the horseshoe structure. The mnemonic factor is a very simple concept that involves the assumption, this is important, the assumption that ancient cultures had notion of the sun apparent movement around the earth and the existence of gnomon solstices shadows, which can be measured in terms of the upright gnomon. This point is important. For Stonehenge, we have here for the latitude corresponding to 54 degrees latitude, the representation of this mnemonic triangle with the sunrise from the winter solstice, in the winter solstice, and the one in the summer solstice. Then the red line here represents the difference in between the winter solstice and the summer solstice shadows. And if we divide this number by the height of the gnomon, G, we obtain a factor that has no units and is only a number, a fraction, but the important thing is that the idea is that the people in the past could have knowledge that this factor could have values, exact numbers like integers or unit fractions. Integers and unit fractions are well, here in the ancient people learned how about several things. They surely have reached the mathematical knowledge like integer numbers and unit fractions, triangles in general, square triangles in particular. I think that the very concept of triangle could come from the observation, like these people here in the picture, of a shadow that is cast by the gnomon in this image. And with this knowledge, the people could have made decisions, important decisions for development, decide where to put cities or caves or finding places to go to be, or the sizes of their instruments, monuments, and other kind of issues. For example, the important here for these people that we can see in the picture will be the height of the gnomon and the length of the shadows at summer solstice, for example, like this, or in winter solstice that will be another height. Then we proceed now that as I said, no matter if we talk about the Ptolemaic vision or the Copernican vision, in both cases, we have the inclination of obliquity of the ecliptic is the same, that has the axis of the Earth. In this case, this is part of the importance of then in terms of these winter and summer solstices, the mnemonic factor could be seen like this. And if we search in the past, could be a written evidence or a not written evidence, but deduced from shadows or other kind of, as I will show, other kind of vestiges or samples, we can see here that, sorry, in this case, the letters are excuse me, the letters are not, this must be theta and phi. And here we have, here we have the way to have knowledge about the obliquity of the ecliptic, that will be this issue, only with the knowledge of the summer solstice shadow and the winter solstice shadow produced by a gnomon of G length. And also we can say where the place was located, where the places is like this. Then these expressions tell us that the possibility to know those facts. And these two points, the latitude and the obliquity of the ecliptic, give us the places around the world and only have the epoch and the site that could be obtained in this way. The importance of this is that cities where cultures were developed very well and has monuments to confirm that evolution, the mnemonic factor becomes takes a value, like, for example, Stonehenge, the mnemonic factor is 3, and Newgrange is 4, and the Mesoamerica, all the region in Mesoamerica, is easy to find a value of 1. This means that if we think in terms of the gnomon, we are saying that the difference of shadows are the same as in Mesoamerica, for example, in the Vilsaltún, where I was working with an analysis. The mnemonic factor is 1. That the gnomon has the length of the difference of shadows. Then now I can examine one that is an example that comes from China. In the book of Shoubi Suanjing, it says that from Shu at 1600 li south of, in the day of the summer solstice, on the winter solstice, there is no shadow. In the 13.500, there is no shadow at noon in summer solstice, in winter solstice. Then this means that the solstice shadows of the gnomon of HG is equal to 1.5 Xi, and at the winter solstice shadow reaches the 30.5 Xi. With these numbers, with this conjunction of numbers, we can use our earlier formulas and find that gave us a latitude of 35.33 degrees and an obliquity of 2402 for the epoch, the obliquity of the ecliptic. Then we can say that this information gives us a place that could be located in China and around the 2900 BC for the date of the notion of these numbers. Then this means that this knowledge can came through eras, through centuries, and to follow this path to get at the end in the Shoubi Suanjing. In this case, I have made the analysis of the place, and I found Jining in Shandong, China, could be the place where Shu is located. That is the place in the Shoubi Suanjing. Let's take about another example of 3000 BC in Serbia. In this case, we have a pattern of circles that is in Bersac, and in this part we have these circles, 5 of them, very clearly represented in the Earth, and the center is located at 45 degrees. As you can see, and 21 degrees the longitude. In searching for the values of the mnemonic factor, we found that the mnemonic factor is 2 1.25, and the Platonic mnemonic factor is 2 2/7 of units. Then we study the sizes of the diameter, the sizes of the circles. This means the diameters, and we can make a discovery that this has a special regularity. What is the special regularity? Here is the algorithm we found if we represent the radius of the of the circles. The radius of an ensign circle is equal to the radius of the first circle and the first circle and, oh, excuse me. The radius of the circle, integer 1, 2, 3, 4, 5, and a factor that is 1.5, and the length of the gnomon. This means that apparently they were defined with an algorithm relating the quantity of 1.5 times the gnomon. In this next picture, I show how this behaves. What is the behavior of this? For example, if we take the size of the first circle is taken as 1, as a unit. Then the second circle is 1 3/5, and the third is 2 1/6, and 2 2/3, and at the end 3 1/5. This means that the gnomon is represented like 0 because it's the unity. 1 point times 3, 4.5, and 6 almost. It's not exactly, but we can have this evolution and to relate this with the sizes of the gnomon. Here we use the shadows that will be cast by a gnomon. In this case, excuse me, I didn't mention this point here. This is the length of the shadow considered for the first circle, and the gnomon would be 8.5 units, taking or meters, 8.5 meters. That makes 3/8 of the gnomon. Then it is important to show here that taking this and the shadows corresponding to these factors, we can have a different approach. Then this means that these circles in color, that are in color in the picture, were done using a GeoGebra program with exactly this algorithm and the values in the table. And as you can see, it fits almost exactly to this, and then we can have a possible calendar. In the grid trilaton of the Stonehenge, the work I said already that the mnemonic factor is 3 times. In this case, the first relation comes from, in this picture, you can see the big trilaton, and we can see almost here a stone that is called the stone 11 in the Sarsen circle, and the relation in between the height of the great trilaton to the height of this will be 3 times. Here is the arrange. This is the Sarsen circle. This is the Sarsen circle. This is the stone 11 that this is not at the same height of this circle. And these are the trilatons. With this, taking these dimensions, we have also 3, 2, 2, and 2, the relation between the stone 11 and different structures in the monument. Let's talk about Pythagoras. What about Pythagoras times? Let us assume that Pythagoras grew in Samos Island around 522 before Christ. Located at a latitude of 37 degrees and a longitude of 26 degrees, you can have that the mnemonic factor gave us a result of 1/3, almost exactly for a place in this place with the winter and summer solstice shadows. Then we can have here the Platonic mnemonic factor is 56. The ancient Egyptian triangle, as I said before, is 3, 4, 5, the size of the number. Then these are the numbers Pythagoras could have measured or known or in some contact with this in this fact, if we think in the possibility of this understanding with the shadows of the known. Then we can say that some sources of the Pythagoras after leaving Samos, he went to Babylon with Cambyses II, and there he learned arithmetic and musical knowledge from the priests. Other sources talk about trips to Delos, Crete, and Greece before finally establishing his famous school in the city of Crotona, present-day southern Italy. In all these places, he could measure the mnemonic factor and could be found 1/2 and 1/4 in Delos and Crete 1/4. This means that in some places located in all, they can be calculated. As I said, the solution of the sacred triangle of Egypt was known well before Pythagoras, but how was the route or the way Pythagoras go from the casuistic arithmetic and geometry, and how Pythagoras gave the basis for the formulation of the famous theorem? Well, the triangle is the definition of the Pythagoras triangle in equations, modern form, but he must have some idea. And I think that, well, the proposition is that with this knowledge of the Pythagoras, of the triangles, like the sacred triangle and other triangles, for example, in the show B, Swan Hing, appears the 60, 80, 100 for locating the sky, and other theorem and he solved this theorem. The distance is found. Then, well, this is all I have to talk, and thank you very much for attention to my talk. I want also to give thanks to Professor Xenofón Musas, not only for the invitation to this meeting, but for his support in the Greek translation, and the organizer committee of the interdisciplinary meeting, Philosophy and Astronomy, for his kind reception. Thank you very much, all.
Thank you very much. And of course, now we have time for some questions or comments, if please. Well, if not, then of course we can continue with the next.
Σταμάτης.
Oh, please. Ναι, Σταμάτη.
Yes, Stamatis. Welcome all together. Dear colleagues and distinct scientists, welcome. MDP feeling grateful and appreciate your participation during these times. We are going through the fellows for the great life full and love and respect. When in 2014, I started my single-handed sailing trip in the shadow of Pυθαγόρας from Samos to Croton. I couldn't imagine any single thing of what was going to follow.
Mm-hmm.
I couldn't imagine that ourselves could make a digital conference for us to connect the world with the stars and philosophy with the techno lives. With Professor Xenophon Moussas, deeply, and the few people, we implement in 2017 the first conference in Samos. Today, we are many, we are more, and we have the honor to invite you all together in the next, in August, International Festival of Samos Pυθαγόρα. All together in the different ways, in digital, in real, in life, dreaming. Welcome in Samos. Thank you.
Thank you very much.
So we can continue with the next talk, and this will be Pythagoras and Mesopotamia, given by Professor Lorenzo Verderame of the Istituto Italiano di Studi Orientali. And please, Lorenzo, we are very pleased to have you with us today, and we are looking forward. Thank you, Lorenzo.
Thank you very much for your invitation. I'm very happy to participate to this meeting, hopefully in the future in person, but let's enjoy what technology offers in this very moment. A few words before I start. I thank you, Professor Moussas, and the organizer for this invitation. I'm on the one hand, I'm very happy because in this very last year, a colleague from philosophy continued to spur me to go through the pre-Socratic philosopher with a comparison with ancient Mesopotamia. So this invitation came as a kind of further element to develop this investigation. On the other hand, I think in this seminar, among very skilled and knowledgeable colleagues, I am mostly an outsider, and I explain why. Since I'm an expert of cuneiform cultures, let's say in this way, so I study Sumerian and Babylonian Akkadian. I've dealt with ancient astronomical and astrological texts, but I'm mostly an epigraphist, a philologist, and an historian. So I apologize for maybe some misused of some terms and some very, very general consideration on the scientific point in my presentation. I'm very happy that I've been preceded by the previous speaker who gave already a kind of overview, or at least one of the points I will deal with in my presentation. So let's go to the point. So I will discuss the possible relation of Pythagora with ancient Mesopotamia. Yes. What we know about the contacts of ancient Near Eastern cultures, and in particular of Mesopotamia, with ancient Greece. In general terms, let's say that the Bronze Age, or roughly the 3rd and 2nd millennium, has two main focus. I will not speak about first or most important culture. I'm just trying to give some definition from the chronological geographical point of view. So we have Egypt on one point, and let's say the ancient Near East with the core of Mesopotamia. Of course, then you have also the Iranian plateau, China, but for my presentation, I will deal with these two cultures. By the end of the Bronze Age, so let's say between the mid and the end of the 2nd millennium, a very important change happened in this world. Mesopotamia, particularly, start to become more and more peripheric to what, by the end of the 1st millennium, is becoming the center of, let's say, the new civilization in very general terms, or the center of new strategic powers, which is the Eastern Mediterranean, and then in few centuries, the Mediterranean tout court. So we know that already in the the 3rd, and probably, but for sure in 2nd millennium, there were contact, economic, political, and probably also cultural, between ancient Mesopotamian and the Mediterranean world. This become more structured and continuous by the end of the 2nd millennium. We have direct, we have direct evidences with materials coming from ancient Mesopotamia found in the Mediterranean. We have the direct references to realities, let's say political or ethnic realities, that will become more known in the successive centuries, like Cyprus is mentioned in letter from mostly of the ancient Near Eastern courts. And we have also some references to what could be identified with, for example, for the Achaeans in the so-called Akiyawa, found in the border, in the Mediterranean border of the Asia Minor. And we have presence, on the other hand, of, let's say, Greek or Mycenaean emporia in the ancient Near East, with vases and other objects coming from the Mediterranean all along the coast of Syria, Palestine, or the Levant tout court. So my point is that there is an increase of connection, of relation, documented in epigraphic and archaeological sources. And what is more important is that is a mutual exchange. So not only elements, cultural, economic, that go from Mesopotamia or from the east toward the west, but also a presence of Eastern Mediterranean or Western people in the ancient Near East. What about the cultural element that we can find in this period? Scholars, in particular in recent years, have developed more and more a conscious perspective on the relationship between, let's say, Mesopotamian literature and art and the early Greek phases. I show you here some of the covers of recent, not really recent, some of them are older, related to these influences of Mesopotamian elements, particularly in the Greek sources. This is Martin West's Face of Helicon, Penglay's Greek Myths and Mesopotamian, and this is a very, very recent work of Hobold on still on literature. The other volume is more general, is from the perspective of Mesopotamia, is a volume edited by Stefan Dalley, dealing with the so-called or presumed legacy of Mesopotamia, so dealing not only with the influence on Greece, but on other cultures like India and so on. So we know from long time that, for example, there are, sorry for the error, theogony, not theonogy, we are elements of contact or parallel between Hesiod's theogony, and this has been fully studied in the past and now by Hobold. We have elements from iconography which are easily and for sure related to ancient Mesopotamia, and then that can give us at least an idea of contacts. Here I put one of the most clear, according to my humble opinion, element that are typical of Mesopotamia. This is the Capricorn, which is half fish, half goat, and is the symbol since the 3rd millennium of the god Enki, the lord of the knowledge, magic, and so on, and many other symbols of the zodiac, which are found at least from the point of view of iconography from the 2nd millennium Mesopotamian, spread both in the West and in the East, and have a different story. So these elements are clearly in their origin Mesopotamian, as many other iconographic motifs. What I want to underline that the origin, the Mesopotamian origin, does not mean that, of course, this literary and iconographic iconic motifs are received in there is a filter in the culture that received this motif as another tradition, and a re-elaboration, so we will not find everywhere and always the same meaning or the exact same element coming from Mesopotamia. But at least in this case, we have a trace of contacts and movement of idea and other elements. Sorry. Okay. So what we know, on the other hand, about the contact between Mesopotamia and ancient Greece according to science. Here we come to a different perspective, because while on art and literature, the studies of these elements and so on has always been marginal, but taken in an open perspective, we have a kind of, let's say, closer reception of Mesopotamian elements related to science and to the study of ancient Mesopotamian sciences in classical studies. This may be due to the idea of the Greek miracle, and I agree on some terms, as I will show, but on the other, the debate should be more open. Indeed, there is no, in general, an absence of academic discussion about the topic of the relationship between Mesopotamian sciences and the Greek sciences in general term, of course, and the Greek one. We have often very important but isolated scholars. I've mentioned only two. Otto Neugebauer, who studied not only cuneiform mathematical and astronomical texts, but also Egyptian, Coptic, and Ethiopic, and so on. And in recent years, Francesca Rochberg has published at least 2 volumes in which she deals with the problem of the relationship between the Mesopotamian knowledge and the Greek one, and in particular in the way modern scholars deal with this relationship. In fact, normally in the Greek sources, and consequently also the classical scholars relate most of the scientific innovation to ancient Egypt. I will not deal with this topic because it's not important for, it's not relevant for our discussion in this moment, but I would like to underline as, for example, a very important scholar who dealt with Greek, the ancient Greek, let's say, scientific or philosophical milieu or perspective, as Lloyd, was written a lot on pre-Socratics. When it comes to a comparative, he normally does this comparative with China, and we almost never found mention Mesopotamian, which, as we know now, a consistent number of sources from the point of view of mathematics, astronomy. I will not deal with other sciences like medicine and so on. So in some point, from some point of view, it's really hard to understand this hostility toward Mesopotamia. This could be again a perspective related for what was, let's say, the Orient for the Greeks, and in my opinion, the problem with the Persians. So a kind of also preference toward Egypt instead of Mesopotamia. What is important for me, and I think is one of the perspectives that should be developed in future and must be one of the main focus of scholar, is not to identify parallel or elements of Mesopotamian tradition in Greece and vice versa, of course, because now it has become more and more evident that you can find parallel. Of course, you have to justify parallel. It's not that you find some element in one culture and another element in another culture. But from my point of view, and this is not only my point of view, the problem is the nature of the contact. So how and when this element traveled from ancient Near East to Greece, and again, vice versa. I just like to mention 2 volumes that try to deal with the topic I've just discussed. So the way the classic scholars build the idea of ancient Greece as an isolated culture and so on. And on the other hand, some possible hints from other tradition. One is the most famous and controversial Black Catena of Martin Bernal. We can agree, we cannot disagree, but at least he raised the problem. The other is a less known work, very stimulating, by Michael Astur, called Elleno-Semitica, trying to identify the way through this culture and tradition moved from the Near East and the Greece. The only, let's say, comparative study that I know in general term, not as article or what else, is the one from the general work of a very popular book of André Pichot, La naissance de la science, where he deals with Mesopotamia, Egypt, and Greece, also comparing the three cultures. So, coming now to Pythagora, what we can identify as element of Pythagora life and knowledge, tradition, or discipline related to the ancient Mesopotamia. From my perspective, we have to differentiate, of course, direct and indirect evidence for this relationship. So direct, a contact, as we will say, a presumed travel of the Pythagoras in Babylon. Of course, even if this evidence is direct, should be critically analyzed. Indirect references, so let's say parallels or elements which presumes come from the Mesopotamian tradition. Both go through the big problem of the life of Pythagoras. I'm not an expert. I've learned a lot preparing this presentation. There is abundant literature about the life of Pythagoras, and we know that, as one of the scholars say, we have two extremes. So we may know very few if we relate only to the sure sources about Pythagoras' life, or on the other hand, we know too much if we take all the references in classic authors about Pythagoras' life. So we have a further problem of analysis, which is not mine, lucky enough, is of classic scholars, which is the tradition about Pythagoras, his life, and his circle, the Pythagorean, and this tradition, the Pythagorean. We have few sure evidence about, these are some of the evidence about the life of Pythagoras. We know that he lived between the 570 and the end of the 6th century BCE, which is from Samos in Ionia, and at some point, possibly around 530 BC, he moved to southern Italy, Croton. We don't know, according to the tradition, if directly or roaming around. Elea is mentioned in some authors, another important center of Magna Graecia. Another important reference for sure is that he was the creator of what we know as Pythagoreanism or Pythagorean circle. There's a lot of controversy about the life of Pythagoras, related to the fact that on the one hand, it's presumed that he wrote nothing, so he based mostly on oral transmission, oral culture. And on the other, that we have a lot of later, in some cases, very late author that gives a lot of information, even detailed, about the life of Pythagoras. We have, I'm not an expert, at least two life of Pythagoras, from Iamblichus and so on. And there is a really excessive information about his life. I think it's very important to underline that we have at least two authors that mention Pythagoras, which are almost contemporary to him. One is Xenophanes of Colophon, who wrote many satires, and one is about Pythagoras, and he mentioned the idea of transmigration of the souls, so metempsychosis. So we can for sure know that Pythagoras was known to his contemporaries for this theory. Another mention by a contemporary author of Pythagoras is in Heraclitus. Then we have three authors that wrote about Pythagoras in the 4th century, but the most relevant information we have about Pythagoras are from authors from 1 millennium after Pythagoras, and we will deal with this en passant in the next slide. So just to give an idea of what really we know about Pythagoras, how we know these things about Pythagoras. We always have to remember that we have very few detailed information from contemporaries and a lot of information from later authors that created an idea of Pythagoras and Pythagoreanism according to the tradition and the traditions, because many have claimed presumed different identity and personality of Pythagoras according to their own perspective. So about the few things we know about Pythagoras that Pythagoras theories according to this author that we can relate to the ancient Mesopotamia or the Near East or with other culture. One of the main points is the question of oral transmission of his knowledge. So the presumed idea that Pythagoras wrote nothing. This aspect is well known in the ancient Near East, in particular from Assyria and Babylonia of the 1st millennium, where most of the knowledge is transmitted within the scribal circles, which are mostly families, and everything is transmitted from the mouth of the master to the ear of the disciple. So this idea of the oral transmission is well known in the ancient Near East, but now, but here we come to another aspect that, according to the most important scholar of Pythagoras of the recent years, this is a late tradition about Pythagoras. That is to say that Pythagoras indeed wrote something. This has been lost, and the idea of the oral culture, oral transmission would be later, so apocryphous tradition. We know that he dealt a lot of numbers and numerology, and the idea that numbers are the real essence of the universe and everything could be understood through numbers. This has a direct parallel in Mesopotamia, where indeed numbers are, we can say, the base and the column of the economy and the state. We have since the 3rd millennium a very developed mathematical knowledge, mostly practical, as we will see. And since the beginning of the cuneiform tradition, from the 3rd millennium onward, we have a kind of a theological, hermetic, scribal reflection on numbers. So from the beginning of the 2nd millennium, we have numbers for the gods, We have some cryptical, few indeed, text which are all written in number, kind of ciphered text. And from the first millennium, we have esoteric commentary with equation of numbers, letters, planets, trees, metals, and so on. So this idea of the relationship between signs, letters, even if we don't have letters in cuneiform, but ideogram and syllabogram, and numbers and other aspects of the reality is well known and become fully developed in a kind of theological perspective in the first millennium BCE. Just one moment, I apologize because I can't see the clock. Okay, I think I have 5 minutes. Can you see my
Yes, very well.
Yeah, thank you. I will go a little bit faster. And also the aspect, this aspect of numerology that will be developed in what is known in the Hebrew tradition as gematria and notaricon, so kind of esoteric knowledge through numbers and equations with letters and symbols, is related also to planets, mathematics, and so on. Other aspects of Pythagora discipline and Pythagoreanism is on the other hand not known in ancient Mesopotamia. So the idea of transmigration of the souls, at least for the cuneiform tradition, that is from the 3rd to the millennium to the mid of the 1st millennium, is almost unknown. And this is also the case of vegetarianism and kind of dietary rules. We have, of course, taboo and diet prescriptions in ancient Mesopotamia, but we don't have a philosophy in this sense that could be more related to Iran and India. Iran for this kind of idea of the souls, I think the Fravashi, but this is not my field of expertise, or India to Kur. And for the dietary, we could recall maybe the gymnosophist mentioned by Diogenes Laertius, that is Indian sage traveling in ancient Near East and Eastern Mesopotamia. So, what about the scientific knowledge, Mesopotamian scientific knowledge and Pythagora? As I said, we have abundant evidence, and when I say abundant, we have thousands of astronomical texts, very less information about mathematics and geometry, but still evidence, and so on. An important, very important point that should be emphasized is that all these sources coming from ancient Mesopotamian were practical, in fact, so is applied mathematics. We have a problem and exercise on the one hand, and reference works on the other hand, so a list of stars or a list of coefficients and so on. We don't have this perspective that will become philosophy of the Greek, and this is the real Greek miracle, this idea of demonstration of laws and principles. We never found this idea with perspective or this interest in Mesopotamian sources. I will go faster because the previous speaker show some elements. We know from ancient Mesopotamia evidence that the theorem of Pythagoras was somehow known, or best to say applied, since the 18th century. We have at least three sources that show that the theorem is applied. We have later sources from the Seleucid period, but from this period, we can imagine that there was already enough contact between Greece and Mesopotamia, so it's not worthwhile to discuss if it's Mesopotamian or Greek. These three sources from the 18th century are indeed different, because we have a list of coefficients. Sorry, to whom might be interested, I refer to the important volume of Eleanor Robson, Mathematics in Ancient Iraq, from which I take some of the sentences I will quote, because I'm not a historian of mathematics nor a mathematician. For example, the tablet Plimpton 322 is a list of coefficients, and quoting Robson, the central two columns list the widths and the diagonals of 15 right-angled triangles, apparently sorted in descending order of acuteness. The first surviving column seemingly lists the ratios of the square on the diagonal to the square on the width of each triangle. The other text always mentioned and shown is an exercise tablet, so it's written by a pupil, by a student, came from the Yale Babylonian collection, where he found the length of the squares diagonal by multiplying the side by the constant exactly as stated in the coefficient list, in another coefficient list. In both cases, so we have practical. One is a problem solved by the student. The other is a list of coefficients that show that a kind of knowledge of this idea developed from the point of view by Pythagoras, but the rule has never been demonstrated or stated. I will go now very quickly to my conclusion. It's possible to trace a direct connection of Pythagoras with Babylon or the ancient Near East. The later writer, like Herodotus and Isocrates, mention a travel in Egypt, while the very later, almost 700 or 7th century, sorry, or 8th century after Pythagoras, Porphyry of Tyre and Diogenes Laertius or Iamblichus mention a travel to Babylon with the soldier of Cambyses. We don't know if this is real or not. We don't know if Pythagoras never traveled in ancient Near East, but what we know is that, on the contrary, ancient Mesopotamia was present in the island of Samos. These are four very interesting objects. They are bronze figurine. We don't know if they were part of furniture or cauldron or what else. They are for sure of Mesopotamian, if not Assyrian origin. This is the Mushkushu, the beast of Marduk. These are other iconic motifs well known in Mesopotamian. And they were found in the temple of Hera in Samos, whose tradition shows some other connection with the ancient Near East, like the fact that during the procession of the goddess, we have the bathing and the dressing of the statue, which were one of the crucial points of the annual festival of the god and the statue in ancient Mesopotamia. I will not go further. I can share the PowerPoint. Who is interested can go through these references. So we know that Assyrian people or Near Eastern people were present in Samos in the first millennium BC and devoted some object to Hera in Samos. So other sources in the conclusion, like the small treasure of Near Eastern seals found in Thebes in Boeotia, show that the relationship, not only economic, but also political and cultural, with ancient Greece and Mesopotamia already existed by the first millennium. So we don't have to prove this. On the one hand, so we have that Mesopotamia was present in the West. The trade and the way culture, literature, art, and so on moved and were received in Greece. And on the contrary, the wave Greek motifs were received in Mesopotamia are still to be investigated. What we know is that scholars, people, goods always travel in the ancient Near East and the Eastern Mesopotamia. And the idea that we have of Pythagoras as one of the most ancient and most prominent traveler scholar of the antique, moving at least from Samos to South Italy, if not in Egypt and ancient Mesopotamia, is well proven now by the sources. Thank you. I hope I've given my lecture in time. Okay, exceeded 4 minutes. I apologize and thank you.
Well, thank you very much, Lorenzo. There is no problem at all with time. Well, first of all, we're in Greece, but not only for this, mainly because we have the luxury of having a long period between the two sessions, in fact. And please, questions? Excellent talk, of course.
Thank you. Thank you.
Questions? If not, let me say that I once had the opportunity to be in archaeological excavations in a place opposite Jericho. That was in Jordan, well, in today's Jordan. And there I realized that from time to time they could discover several things that obviously merchants brought from Greece, the oldest of which was around the 14th century BC. And of course, civilization is universal, and people used to travel much more than we imagine today, at least.
Μια σώπα λίγο, μπα. Σώπα λίγο.
So, of course, as you said, Lorenzo, and we thank you for the excellent talk.
Μην μιλάς
People have
λίγο.
been exchanging ideas, and they have a common civilization to an extent, even
Ξέρω
from
πώς
that.
θα βγάλω την εικόνα.
Thank you. Yes, with the colleague archaeologist, we dealt with Mesopotamian, and we found this idea of traveling, for example, artisans that they move according to their interests. So we know that there were Eastern Mediterranean artisans in Assyria. And now I'm not an expert, but in Ugarit, for example, in Syria now, there is a Mycenaean small enclave or village, what you want. It was a kind of emporium of Mycenaean merchants. So yes, we have this idea modern that we travel more, but before was the norm to travel around.
Yes.
Absolutely, I agree.
Thank you again. Oh, please, Stamatis.
Stamatis, I wanted to add something, not to add, to think about. In Italian, there is una frase, la quale dice che non portare vasi a Samo. Quelli vasi, perché non abbiamo esaminato i vasi per vedere gli idraulici degli antichi, dei Sumeri, di Egizi, non abbiamo lavorato sulle materie, perché in academic studies puoi trovare solo quello che è giustificato. E allora, scusi per l'italiano e l'inglese.
Perfetto, avessi io a conoscenza 1/10 del greco, che le ha dell'italiano sarei contentissimo.
Intanto, in this case, we can evaluate the materials with the environment, with the academic work, in order to arrive in a complete concept, not real, but demonstrated.
Yeah, absolutely. Thank you. And compliments for the Italian, as I said. I'm sorry, my Greek is a classical Greek knowledge from the high school, so I can't reply in Greek. I have to say that in recent years, the development of archaeozoology or paleobotanic or archaeometallurgy has done really giant step in the evolution. So the analysis, for example, of the provenance of the metals could show very long distance travels from Central Asia, or for example, for the second millennium, Cyprus was the main source of copper for the ancient Near East. And now we know, for example, that many animals, we already knew, but now it's proven scientifically, many animals in Mesopotamia, introduced in Mesopotamia, comes from India. So, and also many vegetables. So yes, the problem, because I'm not an archaeologist, or a philologist, that with scientific evidence and material evidence, you can trace these passages, for example, also the analysis of shipwreck in Greece or along the coast of Turkey. But when you come to culture and scientific knowledge, there is also this shadow border, because I don't like the idea that everything comes from Mesopotamia. I mean, we have thousands of texts, they are earlier of other culture, so you automatically think that everything comes from Mesopotamia, but we have people like the Urian in the Near East that never wrote down anything, and many motifs can come from this culture or culture that are not yet discovered or proven. So the problem is, yes, we found elements of Mesopotamian in Hesiods, but we don't have scientific proof like metals or archaeometallurgy to understand who influenced whom and the rest.
Excellent. Thank you very much again. And now we continue with Professor Elio Antonello from the Astronomical Observatory of Brera. Elio will talk about Plato and the solstices. And I have to add that I continue to be grateful to Elio because he inspired the title of a conference I prepared in Athens that was Astronomy, Mother of Civilization, based on a phrase that he said once, quoting Plato. But please, Elio.
Thank you, thank you. Okay, good morning to everybody. Thank you for your invitation. I will give a short talk. In my opinion, there is a significant relation between the very practical consequences of the ancient observational astronomy and the history of the culture. I mean, a relation right at the basic level. Just as a starting point, let me begin with Roger Penrose, who in the large book, The Road to Reality, deals also with Pythagoras, a little bit with Pythagoras, and of course, Plato and Platonism. However, here I will recall just the prologue, the few pages of the prologue, where Penrose tells a detailed story that begins with a destructive earthquake and tsunami following the third eruption about 1600 BC. Penrose imagines some people after the disaster that are asking themselves what deep forces control the behavior of the world. Because after the enormous destruction that changed the environment, the stars in the sky did not show any change at all. Time after time, the tale of the disaster was then handed down from father to son, along with the same question. On about the 6th century BC, a man looked up at the heavens. He puzzled over why the gods had not organized the stars in a more appropriate way. Then an odd thought overtook him. Do not seek for reasons in the specific patterns of stars. Look instead for a deeper universal order in the way that things behave. That man then took to the sea. He found his way to Croton, where the sage and his brotherhood were in search of truth. The name of the sage was Pythagoras. This is the tale about Penrose, of course. But how could we look for a deeper universal order? A possible answer is that of Galileo Galilei. Everybody knows, I think, this sentence. Since the universe is a book written in the language of mathematics, we have to understand such a language. That is, the numbers, triangles, circles, and so on, for looking the deeper universal order. And I mention right now what Plato affirmed, that is, that the numbers, the hidden numbers, were invented looking right at the sky. We will come back later on this strong affirmation. We will start now our journey. The very practical consequences of the observation of the sky in the far past had to do with farming, the hard work that must be done at the right time. The Latin author Columella, 1st century Corinthian, in his manual on agriculture, writes that there is an insidiousness, insidiosissima con tanti, insidiousness in agriculture, as it was expressed by the very, very ancient poet Hesiod, vetustissimo author, very, very, very ancient poet. The ancient Latin writers were well aware that Hesiod lived in the antiquity. Today we'll say many, many centuries before them. Here, Columella quotes, writing Greek, a verse taken from Works and Days. The sense should be that it is very dangerous to postpone the farming activities, because the risk is to delay all of them. If you delay one activity, then the next one is, of course, delayed, and so on. Therefore, it is mandatory to follow a precise calendar. And it was mandatory even for prehistoric people for 1,000 years, well before the invention of writing. And how it was possible. All of you know the motion of the sun in the sky between the solstices. The sun goes forth and back from one solstice to the other along the year. Okay. Hesiod writes, but if you plow the good ground at the solstice, the winter solstice, you will reap sitting, grasping, think, crop in your hand, bending the shaves early, dust covered, not glad at all. So you will bring all home in a basket, and not many will admire you. In other words, the risk is to get almost nothing if you wait for the winter solstice to plough and sowing. That is, you have to plough at the right time between October and November, according to the stars quoted by Hesiod, it is Pleiades, Hyades, and Orion. Let me show you the sunrise from September through March with this simulation with Stellarium, with steps of about 20 days. We exclude the atmosphere in order to see the sun against the stars, the rise, the sunrise. Well, time after time, the sunrise occurs towards south, October, November, December, and now the displacement in December is very, very small. The sun stops here and then goes back slowly and then more quickly, day by day after day. The position of the solstice, I marked it with an arrow, depends on the latitude, as was shown also by Raul Perez Enriquez before. The azimuth is the angle from the north. During the prehistory, people used menhirs, rocks, and stones as indicators, and everybody knows about Stonehenge in England and its orientation towards the solstice. But there are really a lot of examples, very, very many examples of prehistoric solstice indicators. And the solstice was so important that even today, our civil year begins more or less near the winter solstice. And here are some justifications. Ovid, 1st century, current Eve, dreaming of the god Janus, asks him why the beginning of the year occurs in the bad season of winter, while it will be much better to be in spring. And the answer of the god is very short. Midwinter is the first day of the new sun and the last of the old. Phoebus and the year have the same beginning. Midwinter is the solstice. Varro writes a clear definition. The time from the winter solstice, Bruma, to the next one is termed year, is called year. This is the definition. And Plutarch offers an interesting explanation. Speaking generally, to be sure, there is not naturally either last or first in a cycle. And it is by custom that some adopt one beginning of this period and others another. They do the best, however, who adopt the beginning after the winter solstice, when the sun has ceased to advance and turns about and retraces its course towards us. For this beginning of the year is in a certain way natural to mankind, since it increases the amount of light that we receive and decreases the amount of darkness and brings nearer to us the Lord and leader of all mobile matter. I think it is important to realize the slowness of the motion of the sun on the horizon near the solstice. And it was not easy to detect such a very small change from one day to the next in prehistoric times. The observers had to look carefully, even though they had no instrumentation, in order to identify correctly the day of the solstice, that is the beginning of the year, and the determining the length of the year. Here you can see that the change from one day to the next is a very small fraction of degree. It is difficult to identify this. Well, Hesiod writes, when Zeus has finished 60 wintry days after the solstice, then the star Arcturus leaves the holy stream of ocean and first rises brilliant at dusk. And after him, the swallow, appears to man when spring is just beginning, but before she comes from the vines. So in the past, people had to count the days. You have to imagine 1, the next 2, then 3, etc. And in the case they miscounted the number of the day, they had the help of the star Arcturus. We should identify with them. We can imagine the discussions because it is easy to miscount after 40, 50 days. It is 49, 50, 51, big discussion, I imagine. Well, they had the help of Arcturus. Here I show the rising of the stars at the sunset that occurred about 60 days after winter solstice in Boeotia around 8th century before Christ, because the rising and setting of the stars depend on the latitude and on the epoch, on the precession. The exact counting was needed to Beton of Athens. The Metonic cycle, a period of almost exactly 19 years, after which the lunar phases recur at the same time of the year, it is almost an exact number of days, one number of days. The difference is just 2 hours. So Beton judged the cycle to be a one number of days, 6,000, etc., and had to count something like 7,000 days, taking probably the solstices as starting points. And it seems, according to the slide before, that he observed from the peaks towards Mount Lycabettos. That is a very good reference point. If you look at the mountains, the conical shape with the point, very nice point on the top. And now, in my opinion, one can fully appreciate what Plato wrote. According to Plato, the best gift of the god to the mankind was the sight. As by account is it, our sight is indeed proved to be a source of supreme benefit to us, in that none of our present statements about the universe could ever have been made if we had never seen any stars or sun or heaven. As it is, however, our ability to see the periods of day and night, of months and of years, of equinoxes and solstices has led the invention of number. Please pay attention. According to Plato, the number was not invented for counting the flock, the goats, the sheep, the cows, and so on, as it usually assumed by people. Not at all. It was invented for counting the days. And has given us the idea of time and opened the path to inquiry into the nature of the universe. This pursuit has given us philosophy, a gift from the gods to the mortal race, whose value neither has been or nor ever will be surpassed. That is, the invention of the number was followed by the development of arithmetic, mathematics, geometry, and astronomy itself, that is the natural sciences. And the invention of the number was followed by the development of philosophy, that is the group of humanistic sciences. So, following Plato, we should conclude that the whole culture, scientific and humanistic, began with the observation of the sky. And analogous thoughts are expressed by the pupils of Plato in the Epinomics in much detail, very much detail. How did we learn to count? How did we come to have the concepts of 1 and 2? The universe has endowed us with the natural capacity 12 concepts. And the things he shows us, taken one by one, what can we behold more beautiful than the day? Later, when we come to see the night, everything appears different to our vision. And since heaven never stops making these bodies ply their course night after night and day after day, he never stops teaching humans 1 and 2 and 3 and 4, etc., until even the slowest person learns well enough to count. Well, as a conclusion, it seems to me that the strong importance given by Plato to the time reckoning, to the count of the days, for the development of the culture, was inspired by the activity of those observers that tried to define exactly the length of the year and so on, using the solstices as starting points, a procedure that was invented by the very, very ancient farmers. Thank you.
Thank you very much, Elio, for your extremely interesting and beautiful talk, in fact. And of course, now we are ready for questions or comments, perhaps. Yes, please.
Well, I want to comment something about this interesting point presented, and is that these are, again, written evidences that this information comes, for example, from Plato or earlier from Pythagoras, that he doesn't write. But as I mentioned in my presentation, I think that the very concepts of counting comes also on the observation of these solstices, as I mentioned before in my presentation. And I think that we are agree in the importance of these two points of the observation of the sky and the use of the gnomon to represent. I invite you to show, to look for the length of the gnomon that can show exactly the date of the, and not only the azimuth or the of the sun. You can follow at midday, not in the horizon, but at midday, yes, the length of the shadow.
Okay.
Stamatis. In case we wanted to examine deeply the conditions, ancient conditions, must go to the ladies, but must go to the mother of Plato, Perictione. Where Perictione stayed, it was professor of Pythagoras school. In their mathematics, in their philosophy, and all of, must examine the mother and the daughters, because it's the additional through. Thanks.
Excellent.
Well,
more questions, perhaps, or remarks? If not, thank you very much, Elio. And I'm going to continue, and please, Stamatis, make sure that I keep the time, please, because as you know, we teachers, when we start talking, we never stop. I'm going to continue with what I call the signature of Pythagoras in the Antikythera mechanism. And in fact, perhaps even more correct, the signature of Pythagoras to all science, technology, and philosophy then. In fact, as very well Elio said before. The work that I'm going to present is really based on a very long line of works. And here I have the thanks to my colleagues, and especially the team of the Antikythera mechanism. And the secret is always collaboration, as we know. And I want to continue thanking all the members of the team. Probably most of you know that the Antikythera mechanism, as we call it today, is a sort of dedicated astronomical computer that can predict several things, all the astronomical phenomena that people were aware at the time of the construction, or even well before that, at the time of Socrates, let's say, and Meton, if not even from prehistoric times, as we'll see. It is like a double-phased clock, and here I have one that we can see. We'll have more of this in a second. With 2 pointers on one side of the sun and the moon in fact changes continuously phase and position, of course, in the sky, because here we have the ecliptic divided in 360 degrees and named also with the zodiac signs, well, names, in fact. And outside we have what we call the Julian calendar, although it predates the time the Julian calendar has been introduced by 50 or 100 or more years, in fact. It is the so-called also Egyptian calendar, but it is a calendar many civilizations, including the Greek, had in parallel to lunisolar calendars. And people, of course, had to learn to count by counting the days of the month, as many activities, mainly hunting and fishing, were related to the phases of the moon. And they were accustomed to have a 2-month period of 59 days here in Greece, all over, let's say, the Mediterranean, and also in pre-Columbian Mexico, for example, all over the world. And these forced them, Anangi is the name of that goddess that urges the people to do things they have never thought of doing before that. So the necessity of counting came with astronomy, and the prediction of the weather, the exact day of starting this or the other agricultural activity, as issued, as Elio very well introduced to us a few minutes ago. And here we have a calendar, a lunisolar calendar based on Meton that has his observatory, as again Elio presented before, at the very heart of the Greek Athenian democracy, at the parliament that is just opposite Acropolis. And this is a 19-year calendar, the Metonic cycle. In parallel, we have a smaller period. Well, in fact, this is 19-year or 235-month calendar, and another one that is called the Calippic calendar, that is 76 years, 4 times the previous one, and a smaller one, but very accurate as well, that again, I believe was known from prehistoric times, probably millennia before Hesiod, Plato, or Homer, as we have indications of all the measurements that Elio and Raul presented before in sites that go back to the middle of the 7th millennium BC in Greece. Oh, sorry. For example, in Sesklo, where all the buildings, orthogonal buildings, rectangular buildings, built around 6,500, something like that, BC, look towards sunrise of the shortest day, that is the winter solstice. And there are many more details, but we don't have the time to go to that. So this is really the beginning of astronomy, the beginning of geometry, arithmetic as well, to count the days, and mathematics and civilization, probably. And the epitome of philosophy, as I call it, this Antikythera mechanism, is in the National Archaeological Museum. And when you come to Athens, all of you are invited to go together to show you there this very intriguing object that I was mesmerized with since I was a child. My school is only 3 blocks from the museum, so we used to go there frequently. And my parents also, especially my father, used to take me there. And because astronomy was my hobby, mathematics was the greatest love of me, in fact, but they combined with astronomy. And constructions were also a part of my hobbies. I used to go there and stay at least for a few minutes, if not for at least half an hour, to wonder how on earth humans could have astronomy 20-something centuries ago, and how they could have gears that were evident from all sides of this peculiar object. And I'm really very lucky that I had the opportunity with the group that I just presented to you to study it, of course, following previous studies that have started already in first publications, 1903. Just 2 years or 1 year after its discovery. And I'm very glad that now we have a working model of an astronomical clock that includes even the planets, that is a collaboration with the University of Sonora. And here we have Professor Perez and Saucedo with us, probably more, but these are the ones I know that are with us. And with a company of big clocks, relojes Olvera, third generation. And here we have some of the people in one of our weekly meetings, excuse me. Here is the Metonic cycle. This is an 8-year cycle of the Olympic Games. And down here we have the predictions of eclipses. Here is one side with the planets. This is the structure that we have strengthened our knowledge of it with accurate X-rays and especially computed tomography, as we see here. It is very complicated, and the most complicated motion is the one that at least we have discovered up to now, because we continuously have surprises with the mechanism. For example, still we don't know why we have here this eccentric ellipse, well, broken ellipse or cycle. Is not certain because the thing has been broken 21 centuries ago when it sunk into the sea. And the moon goes around the Earth. Of course, it is a geocentric system because it's the only one we can conceive things easily. When we receive the data from satellites, spacecraft, of anything we measure, we receive them from ESA or NASA in several systems: geocentric, heliocentric, joviocentric, eocentric, anything, because you want to see things as they happen in the spacecraft or from the sun or from the Earth. Anyway, it is geocentric, the system that we have here. And the moon goes around in these 29.5 days. The sun, of course, goes in 365 days, and every 4 years there is a way to add one extra day. And the other side has a Doric calendar. This is the Metonic cycle, of course, which is really the calendar we use for the Christian moving festivities or Jewish festivities as well, or with some changes, the Chinese calendar to an extent. And in particular, this 8-year cycle of the Olympic Games is another very important feature. And in the manual, because this computer, as you can see here, for example, and here we have only something like 1/4 of one of the 2 pages that we have from the manual, written on copper with a bit of tin in it, with capital small Greek letters, very close to the modern capital, in fact. But their shapes are the ones we expect for a time period between 150 to 100 BC. It is written in more or less the Koine, the Kini language, the close to Ionian, and because it is a scientific text, it is a very short description of all the knowledge of astronomy at the time focused mainly of what I call laws of physics that they use to predict, for example, the phases of the moon or the metonic period or the period of eclipses, and that is the Saros, or the triple that is called exeligmos. Saros, in fact, means sweeping the sky, and sweeping the sky to know where the eclipse will take place. In the laws of physics that they use for the prediction of this phenomena, we read many resonances of the planets, periodicities of the planets that are the ones used by the Pythagoreans and Pythagoras, as we understand. Although the name Pythagoras is mentioned very many times in the Greek literature, probably more times than the term Greece is mentioned there. But unfortunately, it comes much later in time, as Elio pointed before. These periodicities, and some of them appear here for the first time in ancient literature. We have very long periodicities of the order of 5 centuries, for example. The manual contains what Elio said before, that we try, following Hesiod, to know the exact time of the solstices and equinoxes, because these were the beginnings of the calendars of the various Greek city-states. And let's say Corinth has a different calendar than Sicyon, that is only 15 kilometers from Corinth. And of course, they were always together, and all of them were under the influence of Corinth, that was too strong to let anyone else in the Peloponnese, at least, or all around, let's say, the Mediterranean, to have a go in financial matters, in economics, in let's say the wheat that was going around to feed the people around the Mediterranean, especially in Greece. But they have a different calendar that begins at a different time than the calendar of Corinth, that, as I said, is only a few kilometers away. And there are 40, perhaps 50 lines of these, and they say that when we have the beginning of the rise of this star, you have winter solstice. And 10 days later, another star rises at night. And 10 days later, or 10 degrees apart in the sky, Capricorn begins to rise together with the sun. And then we have spring equinox, so it is the 25th or so of March, let's say, for that time. And then somewhere here, Iades set at night. And and so on. Lyra rises at night, and Pleiades rise in the morning, and so on. So with these, they keep a proper calendar to regulate their agricultural activities as Hesiod and Plato and Eliot just described. So we have some 50 of these lines. We don't have them all, but we have sufficient to know when this happens. A quick look at the manual. Here it says 76 years and 19 years. These are the laws of physics they use to predict the phases of the moon during the phases of the moon during the metonic cycle and during the Callippic cycle. This is Omicron, little o, and it is 70. And this is stigma is number 6. This L is not L, but it is the notation of the year that the Greeks use. Perhaps it is of Egyptian origin, I'm not sure, and forgive me if I'm wrong, but I have read this in the Latin translation of the elements of Euclid that belonged to Copernicus, because I had the unique opportunity to keep it in my hands in the library of the University of Uppsala, where, thank God, our friend, Professor Henriksson, let me in and handle this beautiful book. So this L appears in the Latin translation of the elements denoting the year. And here it says 223 months. And it goes on, of course. It says that the circle is divided. Oh, I'm sorry. And, this is ecliptic months, probably in nominative or dative. And it has a very peculiarity. Instead of having kappa, ecliptic, it has a gamma, so it's ecliptic perhaps. And it points hopefully to the provenance of the writer. And a very important word we read the very first week. Here it says cosmo or cosmoi or cosmo, or of the cosmos. Really, that night, it was after midnight in my office that we read it. Was really very thrilling, I can tell you. And many more. One eclipse. Now this gives the signature of Archimedes probably, because according to the calculations of Dr. Henriksson, using 13 solar eclipses and the lunar, but mainly solar because they are more accurate. From this one, we know that it has been observed in Syracuse. Not just, let's say, Sicily, but Syracuse exactly. Because it says, during that month, Ilios, so the sun, hour, ora, omega, rho, 9. At 9 o'clock that month, that year in the Saros, we have an eclipse, and of the Exelithmos, we have an eclipse somewhere in the Mediterranean, and this comes to be exactly with the method used by Henriksson in Syracuse. But it's not the only, as I said at the beginning, it's not the only signature in the instrument, in this manual. Inside 2 of the 4 gears that give motion to the moon in a way that follows correctly to a very good approximation Kepler's second law, so the variable speed of the moon is depicted properly, very realistically, in the mechanism. And we saw before this shiny, beautiful moon. Inside 2 of the gears, this one at the top and another that is above it. So we have 2 gears, one on top of the other. Right here, we have a pentagon. Now, what is this pentagon really? It's the signature of Pythagoreans. It is the motion of planet Venus as it goes around the sun. And this gives the periodicity of 4 gears, or well, in fact, 8 gears, as we'll see in a while. The 8 years of the Olympic period, it is really the octaeteries, as we call it, and it was used obviously from the beginning of the Olympic Games. I personally believe, in not only me, that it goes back at the time of Noan period in Crete, and probably all over Europe, because we have the same 8-year period in Uppsala, again, for example. We don't have the time to go into details, perhaps another time, at later times, but still. And it was used by some of the Christians in Antiochia, I think, and not only, for the determination of Easter. The pentagon is a symbol of knowledge of astronomy, of knowledge of mathematics, of course, of knowledge of geometry and arithmetic, and astronomy together. Let's have a look here. This is the pentagon that I just told you, hidden without any use between 2 of the very important gears of the mechanism. So here it is, and, excuse me, it really represents the motion of planet Venus, depicted here. This is from Encyclopedia Britannica, first edition, and it comes from similar diagrams that the great astronomer Giovanni Cassini, founder of the Observatory of Paris, has in his writings. So this is really what I call a signature of Pythagoras, but it's not the only one. We have, as I said before, many resonances of the planets. These are the resonances that have been used, excuse me, to create this scale or redefine or, well, make better the musical scale with the notes that we have today. So we have this octateries and the Olympiad, which is the half of it. It's a period of 5 periodicities of Venus, 8 periods of the Earth, 8 years, and 99 periods, synodic periods of the Moon. Now, these numbers we have discovered with Dr. Tsikritsis in Crete, studying various objects, mainly what are called tiganosχημα in Greek, frying pan vessels, they are called in English, otherwise useless things that have been discovered in tombs of ladies mainly. Probably these prehistoric astronomers of the 4th and 3rd millennium BC. Now, also in some other objects, we have these 99 and 5 and 8 numbers. We have the 223 synodic months of Saros and of Meton 235, and also, all these appear again in the manual of the Antikythera mechanism. 2 more totally unexpected periods, 462 years, a resonance of, and 442, Earth, the Sun, Saturn, and Venus. Why? Why they appear? Well, really we don't know, because the manual is fragmented. But these are resonances of the planets. These were knowledge of the Pythagoreans. So all these are what I call, together with the octateries mainly, where we read here Olympia, the Olympic Games, and Isthmia, and Nemea, and Na, Dodona, where Raúl Pérez discovered this important factor of the rectangular triangle and the gnomonic scale with the gnomonic factor. Here we have Pythia at Delphi, and Isthmia again every 2 years, Corinth, Nemea very close to Corinth again, and Argos, and down here is Aleia or Alia, probably of Rhodes. And I suppose that I have finished my time or not. Stamatis. Anyway, I can continue for hours, but I think that this is
Please
sufficient.
continue.
Okay.
10 minutes more, please.
Thank you very much. Here we have another signature of Archimedes. This is from a reproduction of his book, where he has the construction of the simplest possible Archimedes spiral. Now, here he uses two centers and a constant step equal to the diameter of the very first, well, in this case, the very first circle, semicircle. And this exactly we have in the spirals case of the Antikythera mechanism. And here is this very beautiful reproduction of the original that is made of marble that we can admire today in the Musei Capitolini in Rome. And another Archimedes, this is a 4 by 4 meters portrait of Archimedes in outside the Lenin Library in Moscow, which is the National Library, of course. And I had an exhibition of the Antikythera mechanism just opposite this beautiful place in the Museum of Architecture. That's why I acquainted with this version of Archimedes. Now, another signature that we read in the manual is by Hipparchus. Now, Hipparchus lived most of his time at Rhodes. That's why he's called Hipparchus of Rhodes. And he calculated the eccentricity of the orbit of the moon, and this eccentricity is the eccentricity of the circle or the ellipse that I presented to you before in the part of the mechanism that is the subsection of the moon, this broken circle or ellipse, we don't know exactly. And also, Hipparchus, is the one that describes the motion of the moon using the addition of two circles. Now, the addition of these two circles is made by the two gears that I presented to you before. Well, 4 in fact these are, but here we have 2 of them that are eccentric. This is the eccentricity that I've told you. And it is the same in the gears that are slightly offset. They are linked with a pin that is inside a hole that is on the other gear. So we have 2 gears like this, slightly eccentric with the eccentricity of the moon. And there is a hole here and a pin that goes there. And as the blue gear goes around, the other one moves with a slightly variable speed. Totally unexpected discovery in the mechanism. And I can end with the uses we have today for the mechanism. Today, it is a very good educational tool because it teaches, especially the young, and not only, that humans can do whatever they conceive. There is no limit. Sky is the limit, as we frequently say. And all this is done, of course, with human brain and ingenuity, with the technology that uses science, like the one we have discovered in the mechanism and the one we read in the manual, which is very important that we read it there. So with the laws of physics that are exclusively expressed with mathematics, as Plato, as Galileo, of course, and Pythagoras, according to Greek history, first said that we can do science, we can explain nature. But not only this. Recently, I have discovered this quotation that says that Pythagoras and the Pythagoreans, the wise people, learn arithmetic, astronomy, and Teratian. Now, Teratian means construction of monsters, construction of mechanical miracles, and continues, geometry, music, and charm. We know that he learned Pythagoras initially from Pherekides. And after he learned mathematics, arithmetic in particular, then teratopia, how to construct mechanisms and complex mechanisms, monsters. This is really incredible. I have discovered a few weeks ago. And Antiphon was teratoscopos. He could study peculiar things or mechanisms like Pythagoras, and Chilon of Croton, and so on. And Siagros at the time of Homer, and so on. So we have people that know how to study and construct monsters, i.e. mechanisms. We don't know exactly what, but we have at least this. And it goes on. Here it says peculiar mechanisms, again, and various other monster-like things, mechanisms of Pythagoras. So we don't have just one reference. That's why I say that the mechanism is the best example of Greek philosophy and of Pythagorean philosophy, in fact. Like these three words here in a very Pythagorean, well, we call it, of course, Orphic hymns. Three words, all the laws of physics. It says, the law of the sky that puts the stars in their position and motion. Three words. And similar is the very first line of the New Testament of John, where he says, for example, that at the beginning it was the law. And then in the third line he continues, and the law was like God. So we have this notion of the law of physics, that as here, for example, says, Pythagoras is the first one to say that the principle and the elements of the principle are the numbers, mathematics. Of course, this is written several centuries after Pythagoras, but still is the best we have. Ending with this image here. This is a guitar, a lyra, of the end of the 4th millennium BC, 3200 probably before. There are many of them around Greece, the Cyclades mainly. And to construct such a thing, you have to perform the musical experiments that, according to our history, Pythagoras is the first to make. Well, probably is the first one to measure accurately the length, the weights, and even in a way that we don't know, the frequency, it seems, as he related these frequencies with the frequencies of the planets. But many millennia before him, somebody has constructed this beautiful lyra, many of them it seems, and for this one needs to experiment, to measure, to take into account mathematics, geometry, arithmetics, and music. Well, thank you very much, ladies and gentlemen. Thank you very much, the organizers and all. Thank you.